the first part here is looking at this other definition here of what a sequence could be or how you write it down, really. It's the same thing, but it's called the recursive definition. And what you guys did yesterday is the general, okay? So there's two ways to write it. So those a sub n's, you know, with the with the arithmetic and the geometric, there's another way of writing those that it gives you the same exact answers, just in a different way, okay? And there's different reasons why we have the, you know, the different ways of writing it, okay? So the first part, there's two parts to it, okay? And here's an example right down here. You can see there's two parts to it. There's a part where you just say what the first term is. So that's what this one is right here, is that you just kind of declare a sub 1 equals first term, and it's just kind of standalone by itself, and you leave it be, right? Whereas if you remember what we did yesterday, the a sub n has like this first term plus, like, you know, this is what we did yesterday. It has all this stuff, and it's all in one thing. So we're kind of breaking this up into two parts. Where we're starting, right, at the a sub 1 is now kind of separated. And you just write it completely by itself, okay? And then we have this other part where we have the a sub n. Now, recursive means like you have to keep on doing it, right? In other words, we don't have a general formula anymore. We just have a way of getting the next number by using the preceding number, or the, you know, we call that n minus 1 term. All right, so what we do here is we just say, like, if I want to find the next term, like let's say on this one, I'm going to start at 2, and then this right here, this n minus 1, that's like the previous answer that you already got, okay? Previous number or previous answer. And what this tells you to do is to get the next answer, multiply your previous answer by 3, and then subtract 1 from it. Right? And then you could generate the list of numbers that way, instead of having this general formula right here by plugging in 1, plugging in 2, plugging in 3, and getting the numbers that way. So it's just a different way of doing it, and there's a good reason why we have it, and it's useful. When you see recursive, it often looks like this. So let's say if I want to do this and find the first, let's say, 4 terms of this using this rule. So the first one is automatically already given to you. I'm going to leave a little space for a reason here. Right? So there's no work to do because you're already given that number. Okay? And the second one, what you do is you say, well, to get my second term, right, I'm going to do 3 times my previous answer. My previous answer is 2. And then I'm going to subtract 1. And that's going to equal a number. And then I repeat that process over and over and over. So this number right here, you know, we took the previous answer and we use it to get the next answer. And that's what recursion or repeating you know, steps is all about. Okay? So I can get this answer, which is 5, right? And then if I want to get the third term, I just repeat the process, right? And it's 3 times 5 now, minus 1. That gives me the next answer. So again, I just took this, my previous answer, plugged it back in, and that gave me the next answer. All right, we just repeat this process to get as many of the terms as we want to get. All right, so this would come out to 14, and then if I want to do one more, right, I could do 3 times 14 minus 1, and that would equal 42 minus 1, 41. There we go. So it's beneficial to write your work out. I was trying to get, you know, make sure we got through that yesterday. That while you could do these in your head, when you write out your work, you can see the pattern and see how things work. And it makes just more sense when you can see that, especially if you're using some color coding like I am. So it just comes out a little more natural. So our sequence here turned out to be 2, 5, 14, and 41. Notice how this is a combination of geometric and arithmetic, because it has the multiplying from a geometric and the subtraction from arithmetic. So remember, there is such thing as having a strictly arithmetic, strictly geometric, but having a combination is fine. You can also have exponentials, you can have inverse functions, you can have all sorts of stuff. We're just kind of touching the surface on each one. Okay. So we're going to get used to using this format of recursion, and then also I'm going to show you side by side with the yesterday's formula, and so you can see that they give you the same answers. All right, but it's really just kind of getting used to this format and just how to write things down more than anything else. All right, it's not so. The mathematics here is just, can you plug in a number, multiply by 3 and subtract 1 to get an answer? That's as much as it goes. But but writing things down correctly, that takes a little more like, okay, what's the right way to do this? So let's practice on both of these. Let's see here. So like before, these are going to be arithmetic or geometric strictly. So looking at A, is that going to be arithmetic or geometric? What would you say? Going from here to here, the same rule that does go to here, the same rule that goes here to here. What is that rule? Adding 8. So this is an arithmetic. Okay. So we're going to write our recursive form. So we're going to have two parts. You're going to have the A sub 1 and the A sub n. So you always have those two parts. Of course, the A sub 1 is just whatever number is first. And then to find the next term, we're going to say, well, how do you get from this term, right, the previous term? So if I want to find 13, I'm going to use this term, the previous term, and we just call it A to this, A sub n minus 1, which just means the previous term. And how do we get from the previous term to the next term? Just add 8. And that's it. Right. So with this rule, I can go through this process right here, and I could just plug in numbers and say plug in 5, right? That would give me 5 plus 8 is 13. I'd plug in 13. 13 plus 8 is 21. All right, plug in 21. 21 plus 29 is 28. And it gives me this list of numbers, okay? And just to compare these side by side, okay, we have the other definition for arithmetic function or sequences. So it's this one. So I could plug it into here and basically get the same, not basically, but get exactly the same numbers. I have my first term, right, goes right here, plus n minus 1, and my difference is still 8. So you can see, compared the two side by side, it's, you got the same numbers. You got the 5, you got the 8 for the difference. They're just kind of different places. The general has everything in one formula. Recursive has two parts to it, right? They just break it up. And of course, with the general, we could distribute and simplify a little bit. So these have different functions, right? If I just want to get a long list of all the numbers, the recursive is actually a lot faster because you just keep on adding 8 to get the next number, add 8 get the next number. But if I wanted to skip ahead and find like the 352nd term, well, that'd take a long time with recursive because I'd have to add 8 352 times. But with the general, I just have to plug in 352 and it'll give me what that number is without having to go through all the previous numbers. So they have their different functions, right? All right, so give that a try. I think, or maybe, oh no. Yeah, go and give that a try for B here. Right? This one's going to be a geometric, but try to write this new format, which is the recursive, and then also do the general, and let's see how that comes out. All right. So you kind of notice that this is the geometric, right? So you just had to multiply by -3 repeatedly. Okay. So we have our first term, which is just 2. And to get our next term, right, all we're going to do is take the previous term and multiply it by -3. So we can put the -3 in front or after, but it makes a little more sense to put it in front. So to get the next term, if I want to get the second term, I would just take 2 multiplied by -3. To get the third term, I'd take the -6 multiplied by 3, the -3, that would give me the positive 18, and so on. All right. And the previous way would be this, where we find the first term, and then we multiply it by -3. And recall, I made a kind of big point of why is it n-1 on all these? Why does this n-1 pop up? Okay. So if you understand why it's there, it makes a lot more sense why this formula works. So this is saying, like, if I need to get to the fourth term, right? So if I need to get from 2 to -54, how many times do I have to multiply by -3? 1, 2, only 3 times, right? So to get from the first term to the fourth term, I really have to multiply by -3 3 times, which is 1 less than how many terms we actually have, right? So that's why this n-1 shows up. Same thing here. In order to get from the first term to the fourth term, like if I want to find like the fourth term here, I only have to multiply by 1 less than that. I only have to add that 1 less than that, like 8 plus 8 plus 8, 3 times. 1 less than the term I'm actually finding. So hopefully that makes a little sense on why these n-1s keep popping up over and over and over. Okay? But you can always check it. You can always plug numbers back in and make sure you get the actual sequence. And then if it works both ways, then you're good to go. Okay? So let's practice just doing that, right? Let's convert one to the other. So now that you see them side by side, let's practice that. All right? So if you want, a good way of starting this is just getting the terms written down. So you have a list of numbers just like you do here, and then you can convert there. Or if you're feeling pretty confident, you can actually just try to go from one formula to the other and see if it works that way. Okay? But for the most, it's easier just to say, well, the first term is 24. My second term is going to be half of the previous term, which was 24. Then my third term, right, it's going to be half of the previous term, which is 12. So we can keep this going as long as we need to. See the pattern, of course. And then if you have the numbers written down, could you use that to figure out the standard formula? So what do you do to go from 24 to 12, 12 to 6, and right? We're just multiplying by a half each time. So of course, that means 1/2 right there is our R. And we have our first term, which is just 24. And to the n-1. So both of these, right? Both of these will give you the same numbers. So if you want to check, you could always go back here and say, well, let me plug in 1 into here and make sure I get an answer of 24. So if you plug in 1, you get 1 minus 1, which is 0. 1/2 to the 0 is 1. 1 times 24 is 24. And I can plug in 2, make sure that works. So 2 minus 1 is 1. 1/2 to the 1 is 1/2. Half of 24 is 12. And you go through a few and say, okay, that checks out, it works. Right? So there we go. We went from the recursive, right, to the general. We can also go backwards, you know, it doesn't matter. All right, so try B, see how that goes. Give that a shot on your own. Start by maybe writing out the numbers, but if you're feeling brave, maybe you can go directly from one format to the other. Okay. We've got our first term here, which is 2. And we got our difference, which is -5. And we can simplify this. And again, once you have it, you can verify it actually works, right? So do the same thing you did on your homework last night. Now plug in 1. You do -5 times 1 plus 7. Right? Plug in 2. -5 times 2 plus 7. Plug in 3. -5 times 3 plus 7. And so on. And you'll see that, okay, 7 minus 5 gives me 2. That checks out, should be the first term. 7 minus 10 gives me the -3, so that checks out. So you'll know pretty fast if your two formulas are equivalent or not, right? Because when you find your numbers, it will, of course, be identical. Right? So -8 and -13. Okay. So kind of cool. Just two ways of doing the same thing. Okay. And that's about it. And yeah, keep in mind there's the arithmetic, there's the geometric, but then there's some of the problems that are more of just kind of figure out by knowing the pattern, right? By looking at, like, if it's exponentials or something like that, you know, hopefully we can recognize those now, and then just the more you practice, and the easier it gets, okay? So you guys have the homework for this, so I'll give you a little bit of time right now just to work on that, and then maybe round 2 we'll go over the next section, okay?